My name is Daniel Dockin, and this is Module 0, Unit 1. Welcome to Module 0. This is our starting point for understanding invasive non-native plants, and it's all about getting the basics right. Before we can think about control, biosecurity, or legal duties, we need a clear understanding of what makes a plant invasive, how it spreads, and why it's a problem. We'll look at how invasive plants differ from other non-native species, the ways they spread, and the different types of harm they cause. This can be from damaging native wildlife to costing the UK millions of pounds each year. We'll also cover the key terms you'll hear throughout this course, so that when we get to more detailed topics like Japanese knotweed identification or biosecurity implementation, you'll already understand the language and the concepts. This module is your entry point and will be the foundation of your learning for everything considered invasive. When we talk about invasive non-native plants in the UK, there are two key points to remember. Firstly, it's non-native, and secondly, it's causing harm. Non-native means the plant didn't naturally evolve or occur here. It was typically brought in by people, sometimes deliberately, such as for ornamental gardening or farming, and sometimes accidentally, like in contaminated soils or goods. Causing harm means the plant has traits that allow it to spread quickly and dominate an area. This harm can take different forms, such as environmental harm, like crowding out native plants and reducing food sources for wildlife. Economic harm, by causing expensive damage to property or infrastructure. And health harm, such as causing burns or allergic reactions. This is also where we introduce the term propagule. A propagule is any part of a plant capable of producing a new plant. This includes seeds, spores, bulbs, corms, tubers, rhizome fragments, and stolons. It's an important word because it covers both seed-based and vegetative reproduction. The most famous example of an invasive non-native plant is Japanese knotweed. It was introduced as an ornamental plant in the 19th century and quickly escaped into the wild. This plant's main propagule, or the way it spreads, is via its rhizome. It can easily outcompete native flora, reduce biodiversity, and has been deemed a nuisance to the housing market. So when we use the term invasive plant or invasive non-native plant in this course, we are always talking about a species that is both non-native and causing significant negative impacts or harm. Understanding invasive plants and how they spread is a key tool into reducing their future spread. Spread pathways or vectors are typically split into two main categories. First, it is naturally or without human involvement. Wind disperses lightweight seeds such as those seen with giant hogweed over long distances away from the main plant. Watercourses are one of the most important vectors. Rivers and streams can carry seeds or plant fragments downstream, quickly spreading infestations along riverbanks. This is often seen by plants like gunnera. Animals also play a role. Birds eat berries from cotoneaster and spread seeds in their droppings, while mammals can carry propagules in their fur. Finally, even gravity plays a part. Seeds or fruits can simply roll and drop downhill. These natural processes mean invasive plants can establish in new locations, even without human activity. This is why they are so challenging to manage. While natural spread is important, human-assisted spread is by far the most common cause of rapid and long-distance movement of invasive plants. Direct spread happens when we physically move contaminated material. This could be in contaminated soils, compost, or even fly tipping. These are all examples of scenarios where we could see the start of a new infestation. Indirect spread is often accidental. Propagules can stick to machinery, vehicles, tools, footwear, or even clothing. Maintenance activities such as roadside verge cutting or railway vegetation clearance can move invasive plants along long distances. In aquatic environments, boats or fishermen can carry fragments of invasive water plants between lakes and rivers. Human-assisted spread is dangerous because it moves propagules much faster and over much greater distances than natural dispersal could. Most large infestations can be traced back to human activity. We've looked at natural spread and human-assisted spread. But why is it so important to understand these two vectors? Together, they're the main drivers of infestation. By identifying how a plant is spreading on a site, whether that's through watercourses, birds, boots, or machinery, we can target management more effectively. It also allows us to break the cycle of reinfestation. If we only treat the visible plants but don't address the way the propagules are moving, the problem will simply return. Understanding spread reduces long-term costs. Preventing new outbreaks is always cheaper and easier than controlling established ones. This is why the PCA Code of Practice for invasive non-native plants makes it a core principle, but also this understanding prepares us for the golden rule, which you'll see and learn about in Unit 2. Stop the plant from spreading and you'll stop the problem from growing. Let's recap. Invasive plants spread when their propagules, whether seeds, spores, or plant fragments, are moved to a new location. Natural spread happens through wind, water, animals, and vegetative growth. Human-assisted spread happens when propagules are moved by transport, vehicles, equipment, or other human activities. Human-assisted spread is usually faster and over longer distances, and is the leading cause of large outbreaks. If there's one key idea to take away from here, is preventing the movement of propagules is the single most effective way to stop the spread of invasive non-native plants. The risk from invasive plants isn't limited to the countryside. They affect everything from busy urban areas to delicate wildlife habitats. Plant Atlas 2020 found that more than half of the plant species in Britain are now non-native. Most are not invasive, but when a species does become invasive, the impact can be severe. These plants can change the physical and chemical makeup of soils, alter water flow, and block sunlight from reaching other species. The knock-on effect is a loss of what we call ecosystem services, the natural benefits we rely on, like flood protection from riverbank vegetation or the pollination of crops. From an economic perspective, invasive plants are a major cost burden. The CABI study estimated that all invasive non-native species cost the UK economy over 4 billion each year, and plants are a significant share of that. For example, Japanese knotweed alone is estimated to cost around 246 million annually to control. Other species like rhododendron, giant hogweed, and buddleia each add millions to that total. One of the reasons they are so costly is their ability to produce huge numbers of propagules, whether that's seeds, rhizome fragments, or other plant parts, which can easily spread and establish new colonies. If these propagules are not contained early, control becomes exponentially more expensive, especially where construction, infrastructure, or public safety are affected. So the threat is twofold, environmental and economic. and it all stems from how easily these plants can reproduce and spread. Are three of the most recognized invasive plants in the UK, and how their propagules drive their spread. Japanese knotweed spreads almost entirely through rhizome propagules. These underground stems store energy and can produce new plants from tiny fragments as small as a fingernail, making complete removal extremely difficult. Himalayan balsam uses explosive seed pods to launch propagules over 7 meters. These seeds can also float downstream, quickly colonizing new riverbanks. Once established, they outcompete native plants, leaving bare soil in the winter and increasing erosion risk. Giant hogweed produces thousands of seed propagules, which can remain viable in the soil for several years. In addition to its environmental impact, it poses a serious public health hazard, as the sap can cause UV sensitivity, leading to severe burns when its skin is exposed to sunlight. We'll cover the identification of each of these species in much more detail, with Japanese knotweed in Unit 4, Himalayan balsam and giant hogweed in Unit 5. For now, remember that in each case, controlling the movement of the propagules is our number one priority. This slide lists the key terms you'll come across in invasive plant management. Most describe a plant's origin, how it behaves, or its legal status. We won't go through all of them. However, the most important new term for this module is propagule. Remember, that's any part of the plant capable of producing a new plant. This can be a seed, spore, bulb, corm, tuber, rhizome fragment, stolon, or other part of the plant. Understanding what a propagule is and how it can move is central to managing invasive plants effectively, because everything we do in prevention and control is about stopping propagules from reaching new areas. In this unit, we've built the foundation for understanding invasive plants. You now know the definition of an invasive plant, how to distinguish it from other non-native species, and the central role that propagules play in their spread. We've explored both natural and human-assisted spread, looked at the threats invasive plants pose to biodiversity, habitats, ecosystem services, and the economy. We've also introduced three high-risk species, Japanese knotweed, Himalayan balsam, and giant hogweed, that you're going to learn about more later to come in this course. Finally, you've been introduced to key terminology, including the word propagule, which will appear throughout the rest of this training. In the next unit, we'll build on this knowledge by looking at the core principles of invasive plant management, including how to break pathways of propagule spread.